What's up? I'm recording September 1st, and I wanted to show an example. There's one in Unit 5 on looping. I didn't click on the specific question, but you'll know it when you see it. It says we want to get a program with the following output. It says it wants to print 10, 20, 30, etc. to 100. Okay? So they want to print certain amount of numbers and then stop, and they say you should only have one line that actually says print, right? Because they don't want to just print 10, print 20. That would work, but that would be horrible because it would be super long. And imagine you wanted to change it. Imagine you wanted to do like, oh, I want to do every 8 instead of every 10. Well, you'd have to go in and fiddle with each one instead of changing like the rule, you know. So they say you want one line for printing, some kind of loop. It doesn't tell you which one. And that's pretty much it. So I wanted to show how there are a lot of different ways to do it. Theoretically, there are infinite ways to do it, just like for anything we have. Okay. So for example, let's say the while loop was the first part of Unit 5, and let's say you're still in that frame of mind and you want to use a while loop. You could say, while x is less than or equal to 100, you're gonna print x and then bump it up. Okay, you got to start it with something, so we'll say x is 10, and so it'll print, bump it up, keep going, print, bump it up. And if I didn't do anything dumb, I think this will work. Hey, it would. So if you type this for that one, it would work. There are a lot of other variations you could do. For example, you could start it with 0 and then bump it up before printing, and then you get the right thing as well. Oh, we'd have to take this off. So you can move those, that's fine. That's already a couple different ways to do it, and that's not even getting to the best way yet. So this question was in the for loop section instead of the while, and the for loop does fit a little bit better. If you imagine like anything in real life where you're doing some kind of repetitive action, there are a lot of different ways that you might start or stop. I think the example I used last time was, let's say you're peeling potatoes. Okay, you're going to make mashed potatoes at home. And your job is to peel potatoes, and you have a little loop, like some instructions in your mind of like, okay, I hold it in my left hand, I run the peel across, I turn it a little bit and run the peeler, and then I turn it until it's done, and then I rinse it and put it in the stack on the right. There are a lot of ways that might be tracked or managed. For example, there could be a pile on the left, and you're supposed to go until it's empty, and you've got the pile of peeled ones on the right. Or there could be somebody handing them to you, and you just keep going until they stop handing them to you. Or there could be, hey, do 10 potatoes, and you just do 10 potatoes regardless of how many other ones are still undone. Or it could be that you're testing it, like, I need 5 pounds, and so you go at the end of each one, you check, do I have 5 pounds? And you do that. Or it could be, hey, we got to start cooking at 5:30 p.m., so do it until 5:30 hits and then start with whichever ones you've got. There are plenty of ways to sort of run the loop, and while and for are two of those ways. let's imagine we're going to do this with a for loop, okay? We want to print 10, 20, 30 all the way to 100, but we're saying for instead. And the reason why I think for is better for this, because it automatically creates a variable. We don't have to say like x equals 0 and then start using x. The idea of a for loop, usually you could do it with a list or whatever, but usually a for loop is going to have a variable that's like your counter, that's like ticking up 1 every time, so we can skip the parts of starting it and ticking it up. We can just use it. It's already there. So let's say for something, we'll fill that in a minute, and we're going to print x. People use I for iteration. People use words that actually fit with the idea, like you might say counter or whatever, but it doesn't matter. I've typed x, so let's go with x for the moment. So for the way you use this usually is you're going to say x in range, and then we say what the range is. You could say 10, and if I ran this, it would print like 0, 1, 2, 3, 4. It doesn't start at 1, it starts at 0. So if I ran this, it would go 0, 1, 2, which is pretty close, right? All I need to do is say times 10, or I guess I need to do plus 1 before, and then it will say 10, 20, 30, 40, etc. So that works, and that's only 2 lines, which is half as many as we had with the while loop, right? However, that's still kind of ugly. This thing, if you were looking at this, you wouldn't immediately be able to figure out, like, what the heck is that? Like, if I looked at this in a week and I forgot what I had done, I would look at that and be like, what was I thinking? What is all this? So you want your code to be a little prettier than that. This works, and if you turn this in, that's fine. And the previous thing worked that I was showing a minute ago with the while loop. But I wanted to show you today that there are a lot of ways. Again, there are theoretically infinite ways that you can get the job done. So you want to pick one that looks good, it looks readable, it's nice and clear, you know. So if you did this, that would be fine. You might add a comment that's like adds 1 to counter since counter starts at 0 or whatever nonsense. But I don't like, if it's, you know, if it's weird enough that it needs a comment, maybe we can just rewrite it. Another thing you can do is that the range function can take more parameters, okay? So far, when we've been using input, for example, we only put one parameter, the prompt, right? Would somebody open the door, please? But there are plenty of functions that have more, or more optional ones. And with range, it's a nice alliterative list of parameters. They call it start, stop, and step. Okay, start, stop, and step. So if we start at 10, we could stop at 100, and we can go by step 10. And then we don't need any of this nonsense. We can just say print x. Because it starts at 10, it goes to 100, and it goes in steps of 10. Okay, I don't remember if they told you this in the CodeHS section on range, but they probably did the first two. Now, actually, this is going to be one little tiny bit off if we run it, so I'll show you that. But right away, this is beautiful. I love looking at this. It's got no weird adjustments, no weird arithmetic. It's just showing some simple stuff. So if I hit run, it's going to be so close to perfect, but it stops one before the end. Okay, if you remember, when we put 10, if it was just range 10, then it went up to 9, right? It was starting at 0 and went up to 9. So like the stop part of the range function is what you call exclusive, meaning it doesn't hit it. It goes right up to it. It's a less than instead of a less than or equal to. So we want to bump this up just a bit in order to have 100 included. So we could make it 110 to kind of fit with the theme, or we could make it 101. And then if I hit run, boom, I got it. So this works. The one I had with range 10 and then some arithmetic works. The one I had with the while loop works. And I even showed a variation on that. And there are even more variations we could do with this. But I wanted to show that you're not just looking for the answer. There's not like one perfect, beautiful answer key somewhere and you're trying to hit that. There is a target, but there are lots of ways to do it. So feel free to experiment, especially with this question. Let me show you what it's like in the actual assignment, because it's literally just one line of directions and it leaves it pretty open instead of giving you a million bullet points, you know. Well, my internet isn't loading that page, but okay. It was this guy. The instructions just say write a program that prints 10 to 100 by 10 as seen below. So it doesn't say what kind of loop. It doesn't say anything. You can feel free. And that's how we should be in most of our projects, you know. So that's all I have to say about that one. Does anybody have another one of these guys that you want to put up and review? Okay. Well, that was a 13-minute video, which seems enough for the moment. Although yesterday in my Computer Science 1, I made a video, and then people were asking about a different one, and I ended up making a second video and posting them both, which is fine. They all have a description in the title, so you can click on the one you need. We'll go with this for now, and next time, we're working on your assessment and on your Unit 5. If you're completely done with those and you feel like it, you can look at Unit 6, because we'll do that soon, but it's not an assignment yet. Thanks.